Okay, so we were finishing sequences and we still had left the sandwich theorem. And I just want to do that quickly. I am not going to give you one of these problems on the test.
Dr. Lott,
Yes,
I have a question before you get started.
yes.
Regarding the makeup exam, I remember you saying that we had to let you know which exam we wanted to take.
Yes, so I'll talk about that. I'm actually going to put an announcement on Blackboard about the whole thing.
Okay, thank you.
Okay, yeah, no problem. That way everybody can see everything and get the whole, all the information. Okay, so here's the sandwich theorem. The sandwich theorem says we have three sequences. So let's let AN, BN, and CN. All right, so these are sequences of real numbers. Okay, if the nth term of AN is less than or equal to the nth term of BN, which is less than or equal to the nth term of CN after a certain point. So this is for n bigger than some special n. So after a certain point, so there's some number n, after that n, this is true, and n is large. And we know that the limit as n approaches infinity of AN is equal to the limit as n approaches infinity of CN is equal to L. So AN and CN both go to L. Then BN gets squashed in between, and it also has to go to L. Okay, so it's called the sandwich theorem. Here's an example. So my sequence AN is the cosine of n over n. And I need to determine the limit as n approaches infinity of AN being the limit as n approaches infinity of the cosine of n over n. Now here's the thing. The cosine function goes like this, right? It just keeps oscillating. So it's kind of hard for us to do that because the cosine just keeps going between -1 and 1, and n is going to infinity. So I want to use the fact that we know that the absolute value of the cosine of n is less than or equal to 1. So that says -1 is less than or equal to the cosine of n, which is less than or equal to 1. But that also means then that 1 over n, which is negative, is less than or equal to the cosine of n over n, which is less than or equal to 1 over n. Okay, so I can divide the whole thing through by n. So now when I take the limit as n approaches infinity of 1 over n, I get 0. And the limit as n approaches infinity of -1 over n is just -1 times 0. So I get this, the limit as n approaches infinity of -1 over n is less than or equal to the limit as n approaches infinity of the cosine of n over n, and that's less than or equal to the limit as n approaches infinity of 1 over n. Just plow through with the limit. Okay, but this limit is 0. Okay, so the limit on the left is 0, and the limit on the right is 0. So I have this is less than or equal to, and inside I have the limit as n approaches infinity of the cosine of n over n. So by the sandwich theorem, its limit is also 0. Okay, so the sandwich theorem says if you can squash this thing between two limits that are going the same place, then the thing in the middle also has to be going to the same limit. Okay, any questions about that? Okay.